Hello everyone, my name's Steve Smith. I'm from Atlassian, and I want to talk a bit about practical continuous deployment. The practical part being quite important in this. There's a lot of talk about continuous deployment, a lot of discussion about why you should be doing it, not as much discussion about how you actually get it done as I'd ideally like. I'm going to talk a bit about how we got it done at Atlassian, or at least in one particular case, and just basically talk you through some of the tools and techniques and the problems that we hit and so on. Before we start, I should probably just back up a little bit and say, a little bit about what is continuous deployment. So I'm assuming everyone here kind of basically knows what it is. It's the idea of, continuously releasing our code out into the wild, be it behind the firewall or be it in the cloud, where it's obviously particularly effective. But one of the interesting things I like to introduce the idea about this is that we think we're pretty clever doing this. People who are doing continuous deployment are going, yeah, we did like 10 releases last week, and it was really good. And that's pretty impressive for a software organization. But I was talking to my uncle, and he's a maitre d' at a couple of London restaurants. And how many meals do you do a day? How many covers they call it? So even a mid-range, mid-size restaurant in London will generally do about 150 to 200 covers a day. That is basically people in the line in the kitchen continually building, creating, and getting out the door in complicated configurations with special requests on every single one, and getting tables that all come out at the same time, and they do that 150 to 200 times a day. And we think we're pretty clever if we do manage to get 2 releases out in a day. So this is possible, and this is something that's actually always been done out in the wider world. Look at someone like Amazon or any company that has to deliver things. Anyone who will build you a bespoke computer and deliver it to your door, these people do it continuously. So it's actually quite possible, but we need to just take some of the techniques from the real world in with us. I'm not going to go into those too much right now, but so I think it's like an idea to pin in your head. This is being done all the time now. We're a little behind the times. To give a bit of background to it, who am I? Who am I to talk about this kind of thing? Well, the answer is I'm now a DevOps advocate, which is something like an evangelist. If you ever find out exactly what a DevOps advocate is, please let me know, because I haven't found out yet. I worked at Atlassian. I was originally joined Atlassian about 8.5 years ago as the original sysadmin, although my background was originally a developer. Since then, I moved into what was then called the internal systems team. We now call it the business platforms team. What we did was build the systems that deliver you make the sales through. We processed the money. We were the hole the money came through, if you like. $1 billion have passed through some of the code that I wrote, not necessarily in one direction. Some of it went back the other direction, but there's a certain amount of pressure there. And we wanted to remove some bottlenecks to getting fixes and improvements out the door. So I was tasked with the job of turning our horrible monolithic dinosaur of a piece of code into something we could continuously deploy. And I'll talk a little bit how doing that. That's slightly off topic. But ultimately, it was a question of we were moving towards, it's no big secret, Atlassian's moving towards an IPO at some point, God knows when. If you find out, please tell me of that as well. So we started to have a bunch of requirements, about SOX requirements and so on, and we had to have separation of duties. We had to have, literally firewalled off our production and our development systems, all the rest. How do we do that and still continuously deploy in a way that makes us flexible, agile? We want to bring all these improvements in to, frankly, raise our stock price when we actually do go public. So this is kind of how I got into this situation. So this is what I've been up to for a while, and it took about 6 to 9 months to do this. Now, theoretically, any smart developer and sysadmin can kind of get together and go, right, bang it out, let's do this in an afternoon. You could get this sort of working. The reality is, to do it properly, you have to make a bunch of decisions, and you have to get other people involved in the decisions. And you need to convince them that this is a sane thing to do. And that's one of the immediate bottlenecks you'll find in this. And I will also discuss that, about some of the human aspects of this and selling this inside your organization. But to back up even further, let's just ask the simple question, what am I even talking about? I'm assuming most people have kind of heard about or are vaguely familiar with continuous integration, continuous delivery, continuous deployment. But what do they actually mean and how do they relate to each other? Well, the first one is continuous integration. That's theoretically been around for a while. That's part of the Agile Manifesto was you build all the time. And there's like big idea, we'll build once a day. It's like now, of course, we build on every single commit. And if you're hardcore and using some of the continuous integration tools like Jenkins or Bamboo, or any of the others out there, you can do it on a per branch basis. Every feature has its own branch, and every branch is getting built constantly. That's great. So we're now doing it literally hundreds of times a day. From that, you say, well, if we can build this 100 times a day, theoretically, could we make it deliverable hundreds of times a day? That doesn't mean actually doing the delivery, but say it's a commitment to say our software should always be in a releasable state. We should always be able to go, well, what the hell, just throw it over the wall. In extreme cases, you'll see this with behind the firewall applications like Firefox. You have the nightly builds; it'll appear constantly every day if you want to keep up to date. But this is about delivery. It's not necessarily about the actual deployment. It's about saying we want to keep our software always ready to release. We do that through, we have, as well as integration builds, we have extensive integration testing, we have acceptance testing, all the rest. Those run constantly, and therefore we have a high degree of confidence we're not going to break anything at any given time. Every build should theoretically be releasable, even if it's not necessarily what you want to release. Of course, once you get to that point of view, you may go, well, if we can do that, why don't we? This is the more extreme version. This says that we are going to release every time we have something that is releasable. We're going to, that could be, in extreme cases, every merge onto the master branch. And that's actually quite close to what we ended up doing. And we release that constantly. Okay, if it's ready, it's been through QA, it's been tested, everything, it's ready to go out. Well, why don't you just go put it out there? Why wait? Now, this obviously works best in the cloud because you have that ability to modify the entire world. But it even happens a little bit in behind the firewall software. If you're following one of the, what Atlassian we called EAPs, the early access program, you can get onto that and get beta builds, alpha builds, and if you have something like Firefox Nightly, you'll get constant updates every time they do a new build of features or things that merge onto the master branch. But at its core, throughout end to end, it's about quality. It's about commitment to say we are going to trust our testing and our integration so much that we are prepared to back this up with action. That's not necessarily going the whole way. How much risk you're prepared to take on is up to you. But the further you get down that line, the further you're saying, we have a good testing infrastructure in place. We have QA in place. We have people who can make that call and know when we feel that our software is ready. So the next question would obviously be, why do this? Okay, we can do it, but should we do it? Well, the answer is not necessarily always the case, but I can only speak to what was important to us. The main thing with us was we were releasing approximately once a week. This was because we had downtime with our systems. So we would do it on a Monday morning. I was living in Australia at the time, so Monday morning was pretty much downtime for the rest of the world. So we would just do a dump of whatever was ready on that Monday. Now that was a pain in the ass. So we wanted to release individual features, not just whatever happened to be done. Now, this is a very, very powerful idea, and I'll introduce why it's powerful. It's actually one of the biggest selling points, in particular to some of the people who are going to be most hostile to continuous deployment in your organization. But the idea of releasing what we need to release, not what we have to release in that time window, was very, very important to us, particularly when you're worrying about, am I going to screw the company for a couple of $1 million? The CEO's breathing down your neck. You don't want that. We want to sleep at night. The other one is automation. Our systems at the time were semi-automated, but ultimately required, largely because of SOX compliance, that we had to give the code to somebody else, and somebody else had to install it on the systems, in particular sysadmins. Now, they have quite enough shit to deal with without us dumping more on them. So we wanted to automate this away. Continuous deployment makes you automate things, because it's part of the idea of the agile world of saying, well, if something's hard to do it often, and then you'll make it easier. This applies to continuous deployment. If you're going to have to do this 10 times a day, you're going to make sure it's a one-button press, and you're going to make sure it's robust. We also want to remove the bottlenecks. And again, this was a problem with the sysadmins. We would have a hard time getting time from the sysadmins to do the deployment. When we originally started the team, it was much smaller. It was actually 2 people writing this code at the start. That was fine. We had root on those machines. We could do it ourselves. But as we got bigger and the changes got bigger and the releases got bigger and the requirements and separation of duties got bigger, we needed to start throwing it to somebody else. Who are we going to do it to? Well, the answer is sysadmins. The sysadmins were not happy with that. So we wanted to make it a fully automated end-to-end system that the sysadmins had very little to do with. Then we could distribute the decision-making outside the sysadmin team to the people who really needed to make the decision. In our case, we used the business analysts were the final arbiters of what went out the door, and then they would just press a button, part of automation. And in your organization, that might be the manager, it might be the QA, whatever however you're structured. But the simple idea of it should be easy and it should be repeatable and it should be possible to do it by anyone with the privileges, to make it a lot easier to get stuff out there. So the first thing that's going to happen is your stakeholders are going to also ask the question, why? Stakeholders here are anyone and everyone in an organization. And the more people who are concerned about this is actually a good thing. That's the core of DevOps. Not saying, this is ours, we're going to keep this to ourselves, we'll make that decision. No, that's a silo. If you want to have an open organization, you should query the people who are going to be affected by this. And honestly, if you're doing anything of any importance, it's probably going to be pretty much everyone. So how are you going to sell this to people who may not be all that amenable to the idea of you running around chucking code over the wall every couple of hours? Well, the first one people are going to push back are the users. Now, users are obviously can be customers, they can be internal users, they can be you yourself in some cases. So what's in it for them? Well, the answer is they get their features faster. If they have a bug fix, they have to find a typo on the website, the customer processing isn't working quite right, it's calculating tax wrong, or you want to tweak some of the tax implications, or whatever, you want to change the fonts. They're going to see that much faster, and they can also get visibility of it in a cool bit I'll show you at the end. Continuous deployment will give them much more visibility. The people who are concerned about what the changes are being made get greater visibility of it because you're automating stuff, and I'll show you how to do that near the end. The next one is managers. They're actually pretty easy. I think one of the reasons why Agile became so popular, particularly amongst managers, is because managers are complete and utter control freaks. And they want to know what's happening constantly. They want to know how badly are we screwed, how badly are we overtime, undertime, what's going on. Agile gives you that by having the shorter iterations. You have the ability to measure much more discreetly. You're not going to start the waterfall. You start a project, gather your requirements, and 3 years later you find out it's 3 years behind. You want to know, oh, well, it's a week behind, but we have 6 weeks left. Well, okay, we can do something with that. Developers, again, this is a tricky one, but ultimately they'll get on board when they realize the same benefits of Agile apply here. One of the real problems with getting your changes into a long-term release, into like one of those windows that come up once a month or even once a week, and you need to get your code in there, you have a death march. It might be a mini death march, but you're still there Thursday. If you're going to get it by Friday morning, you're still there late on Thursday night because you've got to get that out. However, if the release goes out whenever your code is ready, it's driven not by the whims of release windows or time zones or anything like that. If you can just say, I'll release it when I'm done, then you can spend that extra 20 minutes getting that last test to work reliably, and then it'll go out then, not when somebody else tells you have to get it ready. That's a really powerful idea. And again, this comes from the Agile Manifesto as well. This idea that you don't have death marches, you're iterating very, very quickly. Finally, the sysadmins. They push back hard because there's a certain amount of work involved for them, and they don't trust the developers, and the developers don't trust the sysadmins. I've been on both sides of that, and let's just say I have a mild case of schizophrenia. So there's this need to convince the admins. However, there's one argument you can make to the sysadmins, and they will love this immediately. If you're releasing one feature at a time, you know who screwed the systems, and you can blame them for it. So you have you release once a week. In that week, 3 changes were made. Dave modified the schema of the database. Alice updated the database driver. James added a new REST endpoint to query, get information out, to have a more interactive order form. That release goes out on Monday, and the database usage spikes through the roof. Which one screwed the system? We don't know. Any of them could have messed that up. And debugging that is going to be a pain. It's going to come down to reproducing it and then getting out Git, bisect and splitting it up. Or you could release each feature separately, and if you're being smart, part of your release process is it pokes a marker into your monitoring systems. All your graphs show you which release went out at that given point. You see a marker and you see the database load spike. Go look at that commit hash. Go choke whoever did that. Sysadmins love that idea. The idea you can finally blame someone for something is great. It's the first time you have that, it's awesome. I remember the first time I caught someone using BitTorrent on network. It was one of the little moments of joy in my life. It's like someone I can actually get for once. So anyway, enough of that. How do you actually do this? So a lot of the discussion about continuous deployment tends to focus on the idea of like the benefits, what I've been talking about so far. How do you actually get this done? And I'm talking about from the idea of how do you do this as a developer through to how do you and a sysadmin, because we're talking DevOps here, you need to cooperate for this. This is a smooth line, and you can't say, oh, it's been deployed, it's not my problem anymore. If you're going to be releasing stuff frequently, you need to work in concert with your sysadmin, you need to work in concert with your ops. In some cases, and this is really quite a good idea, the ops are actually final arbiter of what goes out the door. The sysadmin or the developers have to go to the ops people and say, we want to do a release, and you do a little huddle and say what's in there, because they're the ones who are ultimately going to have to take responsibility for it, but they have the phone number of the person who came and talked to them, so that's always great for them. So, but first, one of the things you're going to have to do is you're going to have to modify your development workflow. There's a bunch of bullet points here. I don't want to go into too much. I'll drag you through them. Most of it's pretty obvious. And it's pretty much best practice now. Whether or not people are doing best practice is another matter entirely. It's like test-driven development. Everyone says they're doing it. It's like teenage sex. Everyone says they're doing it, but no one's actually doing it. So I'll quickly run through quickly what we consider the best practice of doing a continuously deployed workflow, and generally a workflow at all. The first thing is you need to track your requests. Everything. I mean, everything has to go into your bug tracker. Obviously, I work for Atlassian. We use Jira. I don't care. I'm not going to diss anyone for using something else. It works pretty well for us. And I can only really talk about my own experience, and so I will introduce some of the cool features you can do with that a little bit later. But ultimately, everything has to be a request. And in extreme cases, Mozilla and people like Ubuntu do everything. It's like in Mozilla, one of the first things they did when they produced Bugzilla was put a bug into Bugzilla saying we've got to have a party when Mozilla 1 is released, things like that. Ubuntu did that with bug number 1, destroy Microsoft, or don't make Microsoft Microsoft to be the biggest operating system in the world. We put everything in there: feature requests, bugs, the whole works. But I think that's pretty much best practice nowadays. You've got to track it, but you hear stories. Now, this is where we get into, you've got to be modern. How many people are using some form of DVCS, some sort of distributed version control system? Right, actually, maybe better ask the other way around. Who's not using a distributed version control system? One. Oh, there's a couple of little sort of, not me. It's worthwhile, and this only really works with the distributed version control system. In particular, I'm talking about Git, but it doesn't have to be that. We also support Mercurial, at least on some of our systems, and you can use whatever you want. You can go back and use Dart or Darks or whatever. But ultimately, it has to have efficient branching and merging for this to work, because every feature goes on a branch. The master is pristine. Now, there's a lot of different ways you can do this, Git flow and things like this. That's up to you. But ultimately, you have to have a branch that says, this is what we're releasing. And if it lands on this branch, it's going out there. For us, it's master. We don't overcomplicate things. And then we create the branch. We actually tag the branch with the initial ticket. That ticket is the universal ID for your code base of the features that are being released. And this is very powerful, and I'll talk about how you use this later to really keep people happy, and particularly your users. So you isolate your feature work from from everything else. So each feature goes on a branch. And then you test. In our case, what we do, Our Bamboo instance, we use Bamboo, you can use whatever you like, it's not important. But our Bamboo is set up so every time a branch is created, Bamboo is notified and it immediately clones all the tests. Everything that goes on the master branch, the release branch, is run against the feature branch. Now, this means you need a shitload of infrastructure. We run hundreds of machines and then we overflow into AWS. So you can basically fire up AWS instances on the fly. So we pour a lot of resources into this. But that's great because you're pretty sure if your testing is good, and we're back to this quality again, you've got to trust your testing. If your testing is good, you're pretty sure that when you merge back to that master branch, it's not going to break anything. You don't just merge, though. In fact, in the case of our team, and actually I think most teams at Atlassian, we deliberately block direct merges to master. We do that by basically saying you can never push master. You can only push feature branches. Any merges occur via, in our case, Stash, which is our Git system, but there are other ones out there. But it does it via a pull request. You can use Bitbucket, you can use GitHub, or whatever, but you never push the master, you only push the feature, and then when you go to finally say my code's ready to go out there, you do it via a pull request. And we set up rules around this. So we have certain rules that say you must have all your builds must be clean. In fact, you must have a certain number of green builds before you can do the merge. You must have a minimum of 2 reviewers. The reviewers are important. Now, I say you must trust your test code and your test pipeline. That's very, very powerful. But ultimately, software is written by humans for humans, and ultimately humans must be involved in it. So we tend to require that other developers are pulled into the final acceptance before it gets pushed off the feature branch into the main branch. This is also a very powerful tool as well. It's one of those things where we actually adopted it quite organically because initially, everyone sort of hates the idea of code reviews, but it's good, particularly when you're working on a system that has such high risk, and there's $1 billion passing through it, then the idea that you can actually pull somebody else in and go, look, can you just check this? In particular, I'm a technical person. I was never strong at the business logic side of things. Ernest and Allison, on the other hand, who works on the same team, they're like a pretty neutral talent for this stuff. In particular, Ernest could just spot corner cases in the business plan like no problem, no one else I've met. So I would always go, if I'm modifying the business end of things, I'd always go to Ernest and Allison and say, can you review this? I want you to be sure. And they might pick up something that might say, no, it looks good to me. Your tests are great, but ultimately it's software for humans. And of course, things like, layouts and, images are always going to be, require a bit of human input. So at that point, you do you do a pull request, and you pull people in. At that point, assuming it's been passed, it gets automatically merged in, and then it gets automatically released. So what happens is, whenever a merge occurs on the master branch, we run a full release every single time. So what you're doing here, this is what I'm talking about, releasing features. You create a branch, you separate the feature out to only that work which you're doing, very discrete, only the work that's relevant to this particular change, tagged with the initial request for this change, and then when you merge that gets pushed out, and only that. And that gets pushed up automatically, in our case, straight up to our staging servers. Now, at that point, that's when you're thinking, you would look at pulling some other people in, maybe the original customer, maybe the original person who made the bug report or the feature request. You might say to them, go have a look at the staging server, does that look right to you? And they would get involved. QA might get involved. It depends a lot on how your organization is structured. But having done that release to staging, if everyone signs off on it, and ideally you would have some system in place for having an automated sign-off. People can just tick it off and you get enough ticks, you can then push it out. You then push up to production. Of course, what you push to production is not a fresh build, it's exactly what is on staging. Now, you might need some different flags for production. We do that. We switch off some of the things like mail and so on. But ultimately, when you promote up to production, what's in production is exactly what you run in staging. So what you just put up to production, what you just pushed out, is that one feature that you produced. So that's pretty much the development process, and you get basically this one discrete feature goes end to end and pops out onto your production servers in a discrete manner. Now, how do you get it onto the servers? Let's push forward. This is one that really got me. No, everyone was talking about, hey, it's great, we push out hundreds of times a day. Well, how do you actually get this code onto the production servers, or even onto your staging servers? They might be on different continents. So I had to investigate a number of options there. I call this the last mile problem. This comes from the telecommunications industry. You can shove terabytes of data across the Atlantic, and that is trivial to do. You want to get that last little chunk of, Game of Thrones from the routers down to someone's house. That's a pain in the ass. We're talking about tens of millions of dollars of copper in the ground just to get Game of Thrones, or fiber optic if you're in a really, really progressive country, just to get Game of Thrones up to the door. It's that last mile that's a bitch. So this is the same problem. So I'm going to rush through this quite quickly. I'm assuming most people here are developers rather than operations. There's actually an earlier version of this I did when I had more time. I delved into this a lot more. What I will say is you'll talk to your sysadmins, and they'll probably go Chef or Puppet, depending on whatever they are using to handle their infrastructure. That is a wrong answer. Not that I have anything against Puppet and Chef, but they are not appropriate to this. They're very declarative. So you say to Puppet or Chef, this is how I want my servers to look. How it gets there to that state is entirely up to Puppet and Chef. You don't want that. In particular, you might want to say, well, I need you to upgrade the database first, and only then do you push out this new version of the software, or I need database schema changes, I need you to bring things in and out of clusters, etc. So Puppet and Chef are not appropriate to this. Not a problem, Puppet and Chef, just wrong problem domain. There's another way of doing it, which is orchestration agents. Now, if your sysadmins are already using these, you definitely go ahead and use them. The problem with them is you have to install stuff onto them. So imagine you have your cluster of servers out there in AWS or in your, your own data farm, whatever you need out there. Now, orchestration agents are a powerful way of basically performing operations on groups of machines. And this sounds perfect for rolling out software. The problem is if you have an orchestration agent-based system, you need to get orchestration agents out there. If your sysadmins are not already doing this, then they're going to have to roll out a whole new infrastructure just for you to do your deployments. You're going to get some pushback on that, unless you've got really progressive sysadmins and they're going, oh, I've always wanted to do that, in which case, go nuts, it's great. There are a bunch of them. Salt Stack is one. Never used it myself. I have heard good things about it. It's on my long to-do list of shit I need to look at. Puppet Labs also do something called M-Collective. This tells you exactly how different these two paradigms are. So Puppet have a Puppet, obviously, but they also have something called M-Collective, which does sort of what Puppet does, but does it in a completely different way. So this gives you an idea. M-Collective, we've used it internally at Atlassian. It has a number of issues in its implementation. That means that we have a cron job that goes around restarting the M-Collective daemon on a regular basis. So just to reiterate, these are agents that sit on a machine and do things for you. You call out to them and say, I need all of you to, clean the temp directory or whatever, and they will do it. And there's a daemon that sits there. Funk is one. I think it's pretty much obsolete. It's been largely superseded by Ansible. The same guy did it. Bamboo itself is an agent-based system. If you are using Bamboo, if you're feeling very excited, you can use Bamboo agents to do deployments for you. It has a similar problem. If you want to do a lot of orchestration, it's really a build system. You'd be stretching the limits of what a Bamboo agent is appropriate. We do use agents for deployment, but we tend to use them as an endpoint that starts a deployment and then uses other tools to spread the work out through various different machines. But the other way of doing it is use whatever you already have around. You don't have to put a dependency on your servers, you put a dependency on the code which is doing the pushing, which you're already modifying anyway. In particular, you're going to have to set up your build plans to do continuous deployment and so on. Why not just do all the hard work in the build plans where you can control it, rather than having to go out into your infrastructure and get your sysadmins to install extra software? In particular, your sysadmins are almost certainly running SSH on the servers. In production. If they're not, I fully recommend, I think monster.co.uk is a good source for a different job, because you're probably going to want one pretty soon if your sysadmins are not using SSH. But SSH is almost certainly out there. We can actually use that as a transport layer to do automation and then have all the management at the back end. There are a number of tools out there for doing this. If you're really excited, you can actually do it yourself. You just bin bash and knock up a script. That's fine. Fabric's one. I think the Bitbucket guys use that quite a lot. Never used it myself. I did talk to them about it. Capistrano's another one. I know our operations guys are quite big on that. And there's Ansible, which is one of the new hotness, or it was 5 minutes ago. I think it's, we might have moved on to something else by now. Who can keep track? The idea is, though, that basically each of these uses SSH, and you just say, I need you to SSH a bunch of machines and perform a set of operations. Now, you can do that as a very, very simple script, or some of these higher-level tools that are available to us to automate this. Ultimately, this is the solution we came up with. This is not necessarily the best for you. This was what works for us. So we have Bamboo. Bamboo runs our builds for us. And it does that release that I talked about when a merge is made onto the master branch. That pushes out to one of our agents. We have dedicated agents that only do deployments, and Bamboo has first-class support for this. I don't want to turn this into an advertisement, but I'm just talking about what I know myself. But Bamboo has first-class support for the idea of deployment. In particular, if you can have an agent that sits inside your production environment, you can set lockdown rules that says no build can use that except the deployment build. And that can be set by the sysadmins. So that means the big problems with using agents, your build agents to do deployment, is one of your builds might run on one of your production agents. Now your build's running inside your production infrastructure. If you use this idea, you need to separate it out. Bamboo has first-class support for that. But inside that agent, the deployment runs, it uses Ansible, and then it connects to multiple hosts and will do the deployment. In particular, what it does is it will first connect to the load balancer. It will take node number 1 out of the cluster. It will then perform an upgrade of that particular node, run a bunch of tests against it to ensure that that node is up and running correctly. Only then will it put it back into the cluster, and then it will go on to the next node, take it out of the cluster, etc., etc. So it's rolling upgrades. And Ansible has first-class support for this. That's the idea that before an action happens, another action must happen first, and it might be occurring on a different host. It has the idea that you can actually upgrade certain ones in parallel, but no more than 5 at a time, say. And if you get a certain number of failures, you abandon the entire rollout. Ansible was explicitly created with the idea of this rolling upgrade system and large scale. We use SSH, which is it goes straight over SSH, and then we do the deployment. So it's over there connecting and rolling across all of our infrastructure, doing upgrades and testing. So that is what works for us. What works for you will probably be something entirely different. But this is just a guideline for what worked for us. And what we did in the case of Ansible, I looked at all of the available options out there, put them into a grid, and went, okay, that's good enough. If I did it again now, I might find something completely different. So please do evaluate. But Ansible is working quite well for us. This is the sysadmins really quite like it now. The devs kind of found it quite intuitive to work with because they are building some of the scripts. So it's been worked out pretty well for us. So I've been mentioning clusters a lot. If you are constantly upgrading, are you not constantly having downtime? This is probably one of the single biggest reasons why it took like 6 to 9 months to get this out there. We had a monolithic app that was stateful. I had to basically re-engineer the whole thing so that you could actually run multiple copies of it and then do rolling upgrades and then slap a proxy. And there's arguments with the sysadmins about what's the correct proxy. Do we want to get a Zeus server? No, we do not want to get a Zeus server. Let's just use HA proxy. No. And we're backwards and forwards. But ultimately, what happened was you need to have, if you're going to do this quite a lot, you're going to have robust software. If it's customer-facing, there is actually one particular system in our system that we'd actually like more to be like this, where we just went, well, run a single version, bring it down, don't give a shit. Because it sat on the back end. Its job was to take our invoices and push them up to our accounting system. Those invoices didn't go over REST. They went over a queuing system. We used Hornet Queue, but you can use whatever queuing system you think's appropriate. And if it was down, those invoices just backed up. And when it came back online, it went, right, invoices to process. That's a great way. If you can actually have as much of your system separated out into that, where it's really not critical anymore, that's awesome. So if you can do that, do that. But ultimately, you're going to have to address this. I would like to go into this in more detail. It is a huge subject in and of itself. I love talking about it because it's largely one of those things that's great, but ultimately unsolvable, almost at the computer science level, but to make a really, truly robust clustered system. But yeah, it's fascinating. The world is getting better for this kind of thing. It depends a lot on your architecture. I can't really help you there, other than say look around and bear it in mind. But it's fun to do. When you get when you get those rolling upgrades going and it's all nothing happens and no one notices. My first continuous deployment and no one in the company noticed. I was like, yes, this is what it's all about. Because really, I need a hobby, don't I? Okay, so let's get back to the end. I've got 15 minutes left. Cool. Let's get towards the end. So you're doing these continuous deployments, deploy. And what the hell is on your servers now? You don't know, unless you've been diligent by tracking everything from the start. In particular, what we do, we use the original bug, or feature request or whatever, your bug tracker ID is to run this from end to end. Now, we have at the back end something called deployment environments. Again, this is Bamboo specific, Atlassian specific. This is just because it's what I know. I've never used Jenkins or any of the other solutions, so I can't really talk to them. So I'm just talking about what I know here. So this idea of deployment environments. Bamboo is a first-class idea of deployment. All it is really much like a normal build task. You can just say, I need you to run this, and then package this up, and then send this down the line. But there's the idea that there's multiple places that this package could go to. In particular, you can have a development. HAL is actually by one of our the first things we continuously deployed, the first thing we managed to cluster. This is real stuff from the actual our real environment. So we've got a development sandbox, we have a staging environment, and a production environment. What's running on each one? Well, Bamboo will track that for you. You really need some way of tracking this. What is where? What is required to get it to the next state? Do we want to roll back, etc., etc.? So we use the deployment environments. They are basically just Bamboo tasks. They look an awful lot like builds, but they can push code out into an environment, be it development, testing, or production. But it tracks them. In particular, you can see here, we've got, in the dev sandbox, we've got release number 82. On the staging, though, we have release number 81 and release 80. And what you can do is you can actually promote these releases between the different environments. So you can actually see which environment has which version running. And that, each release tracks back to the original ticket. Because we're using ticket-based management. This is what I'm talking about when I'm saying about having that, tying it all together and using the ticket ID as the universal ID through the whole build process. So Jira creates this ticket. And it will then notify Stash. Now, or it could notify Bitbucket, or it could notify GitHub, whatever's appropriate. But it says, I need a new branch. A ticket has been created. So inside Jira, you press a button, and it will create a branch for you, and it will automatically do it for you. You could do it by hand, but if you're inside that ticket, you can say, press a button, and it goes off to your productions, your Git repository, and creates the branch for you in the correct format. And then Stash will notify Bamboo. Bamboo will pick up on that branch, start testing it, and pushing that information back to Stash. Stash will then set rules. We've set policy that says you cannot merge a pull request until your builds are green. How do you know the builds are green? Because Bamboo is telling you. So the pull request is deeply integrated into your branching environment. So your testing environment and your source control are quite loosely, but critically coupled, if that makes sense. But at the same time, Bamboo is talking back to Jira, and Stash is talking back to Jira. In particular, it's telling Jira, Bamboo is saying the builds are passing or the builds are failing. and stash is saying, oh, a bunch of commits have been made. A pull request has been raised. A pull request has been approved. Pull request has been merged. This means that back in the original ticket, again, this is a real ticket from our ordering system. With an audit log, you want an audit log for provisioning failures. What you can see here is, if you look at the green box that was highlighted, you can see in development, a branch was created, 3 commits have been merged, 3 commits have been made, 1 pull request has been raised and has been merged. You can see here, if we press a button further down, this is information coming from Bamboo. Your development sandbox, this particular ticket has been the code that was produced as part of fixing this bug or creating this feature has been merged out onto the development sandbox. You can go and have a look at it. It goes out onto, it's gone out to staging, but has not yet gone into production. So the person who raised this ticket has full visibility of the state of the work that is going on around it. Now, this is a sysadmin in me talking. I will tell you now, if you want to keep your users happy, give them as much information as you can, show them how to get it, and they will leave you alone. People hate being kept in the dark. They hate being fed bullshit. But even bad news is good news if they feel like they're being included in the process, and they will leave you alone. This is great. You just give them the tools and you can carry on working and they will be happy. Then they just love this stuff. No one hates anything more than feel like they're having one pulled over on them. Show them that work is occurring. Show them that things are happening. Open up your monitoring systems and let them point things out. Let them reason about things themselves. People want to just get their jobs done in a quiet way, and they hate being kept in the dark. So the key points that we want to take away here is you need to have a clear motivation for why you're doing this. This is a big undertaking to do. It's not without its risks. It certainly requires its organizational change. So you have to know why you're doing it first. That's very important. You have to have a branching, feature-based workflow. That's really important. And most importantly, you have to have cooperative tools and people. Your tools must enable cooperation between your people. This is the heart of DevOps, talking to people. This is the heart of what Agile was supposed to be, but turned into a bunch of tools and turned into a bunch of consultancies. It was about sitting down with your customers and working with them, not against them and not keeping them in the dark. So these tools will help you and your operations, your sysadmins, and your customers all just have visibility of what's going on, and they can all work together. So to bring it back to the original point about I made about food, and really haven't referenced back at all in this, so we'll do something about that, is that it's actually possible to do this. People generate change all day, every day, and they do it with confidence because they've done it 1,000 times before, and they all communicate. You go into a restaurant kitchen, they're all shouting at each other, the chef is shouting at the sous chef, the waiters are shouting at everyone, the maitre d' is just basically screaming. But ultimately things happen because the people are communicating. Even angry communication or complaints are a good thing if it means the communication is happening. And ultimately what happens is food goes out on time, people are happy, and you never, at the front end, they never see any of this. It's all about just getting some good food out there, and it's very possible to do. So that's really the sort of summary. Now, this is the URL for the questions. Also, I'd love to take some questions. I'll also be hanging around, of course, today and tomorrow. I don't know that we're actually using the questions app, but so if anyone has any questions about this, feel free to, we've got a few minutes to talk now, or feel free to grab me later. Hi.
Why do you advocate using branches? Because doesn't using branches kind of go against the continuous delivery, continuous deployment models generally?
The question was, why do we use branches if it doesn't that go against the continuous deployment model? No, absolutely not. So we used to use Subversion. We could never have done this with Subversion. On Subversion, I don't know if you ever try, most people work with Subversion at some point. Everyone? Yep. So he's a poor guy down there. Like, oh, no, it's me. But branching and merging in Subversion just does not work. So when we were using Subversion, we would constantly be merging onto master, and we kind of have to hope that by the time we got to the stage where we had to do a release, it was going to be okay. we had testing and stuff, but ultimately you had a whole bunch of stuff just going in, and then you'd throw out what was important, or you'd throw out whatever was done at the end. In the case, by separating a branch and you merge a branch, you only have one change go out at a time. You can separate your work into continuous deployment. It's not about continuously throwing whatever code is out there. It's about continuously throwing features out there. So you separate your features out, work on them until they're complete, and only then do you throw them out. So continuous deployment is not continuous deploying all work. It's about continuously deploying completed work. And you can only do that if you split the work out into separate streams. If everyone's working on the same branch, you rapidly get all mixed up together. Do you have questions?
There's an implicit assumption that you can actually build and test the release branches with the amount of resources you have for a branching release strategy.
Yes.
If it takes you hours to run the unit tests and, well, an hour and a half to run the unit tests for your app and 7 hours to run the integration tests, and you have teams of huge number of developers, then a branching strategy is just not possible with even multiple machines.
Right, absolutely. Well, the question is, it's absolutely implicit that you have massive resources to do this. The answer is really, well, ultimately you do have to have those resources. I mean, we had a similar problem. We still do to a degree. It was our unit test took several minutes. It wasn't too bad. But our integration tests, we started off like when I originally hacked them in there. When I joined the team, there was no integration tests, and I added them. So like, wait, any integration test is great. Add more, add more, add more. And we're up to like a couple of hours for the integration tests. So we started to parallelize them. So ultimately, you need to break it down. So we actually managed to split them onto multiple resources. The thing is, computers are cheap now. If you've got a huge team, but you don't have the resources, you've got an imbalance there. Computers are cheap. Human time is very, very expensive. A job that I was working on when I was working military in Australia, on a military contract, the answer to our performance problems was it could take quite a long time to run all of our this radar tracking stuff that we were doing. The answer was we were talking SGI machines, these big bench-sized machines, cost like $500,000. The answer was, if it was running too slow, buy a new SGI machine, and now it'll run fast enough, because the time taken to optimize this code would take more developer time than the cost of this really expensive hardware. If you're spending a lot of money on developers, but not actually giving the developers the tools to do efficient testing, then you're wasting developer time. That's 7 hours of developer time that's theoretically been wasted by not throwing resources at it. Wouldn't it be better to throw some machines at the problem and the machines take the brunt of it? You're probably talking about hundreds of thousands of, well, you're probably talking about millions. If you're talking a large team, you're talking about millions of pounds a year for their salaries, and you can't spin up a few AWS instances. You've got a mismatch in resources, I think.
We do. We're heavy Bamboo users, and we have loads of machines, but there's still a problem in that, and it's parallelized. But if it takes too long, then there's a problem in the feedback loop, because an hour and a half on a parallelized system can be too long. Well, 7 hours is too long to know that you have a problem. And so, given that strategy with many developers, it's a natural fit to have our modules all be updated to the latest version. So it's just the feedback.
Right. Oh, cool. Actually, we could talk about this afterwards. We won't get too much finds and ways, but I'd be interested in hearing your story and help out. Hi. Oh, sorry, I might take a question from someone else first. Sorry.
Yes, at one point you said that you can configure, for instance, Bamboo or whatever you have to say you have your filter branch. You're not going to be able to. Well, first of all, you can't push to master. You need to do a pull request, and you're not going to be able to do a pull request unless your filter branch is actually passing, etc. Is there any kind of lock to say, well, actually, yeah, you have your filter branch, but since you branched out, master has changed.
Yep.
So, is there any way to force your filter branch to be pulled from master? So, whenever you do a pull request, actually, you have an updated code base.
Bamboo actually has a feature to do that. I don't know about other systems. I don't want to turn this into a sales pitch for Bamboo, but Bamboo has a feature to do that. You can basically say, okay, you do your pull, your feature branches does its tests, and at the end of those tests, it does a sort of dummy merge into master, and then runs all the tests again. So it does. So yes, you can actually absolutely do that and double check. Hey.
Let's say you've just deployed a new version, and now you've spotted there's something wrong with it, and you need to go back to the previous version. So you need to back out. How do you do that? Is it like another merge request and another set of code reviews?
There is as many ways to do that as there are developers. It's actually twice as much because there's developers and operations. Every single person has a separate idea. It depends a lot on things. Bamboo, again, I can only talk from my own experience. Bamboo has the ability to do that in particularly its employment environment. You have a list of all the features, the releases that went out. You can just press a button and roll back and it'll redeploy a previous version for you. Now, this is where we get into the nasty, nasty clustering world. What has happened if you have modified the database and the previous version is no longer compatible with the database? That itself is a talk on its own. But ultimately, yes, what I would do in that particular case, I would roll back to a previous version and then examine the bad release. The other thing you can do, of course, because you've got a merge request, you can actually revert the master back to the previous previous state before you did the merge. There's lots and lots of ways to do it. That's the least hard part. The tricky bit is what happens if the state of your production systems has changed. What do you do then? Question?
What about if you had your feature branch, so which is consuming an application,
yeah,
and is dependent of that feature?
Oh, yeah. Now, again, this is really coming down to the idea. That gets even more tricky when you're talking about cross systems as well. The idea is if you're you can ultimately branch off a feature branch as well. So you can actually, if ultimately you've got two, either you or another person need to cooperate, well, ultimately this is agile. You need to cooperate. You probably need to pair on this. The other thing is, well, if these two changes are so interdependent, why are they two separate feature requests? Maybe they should be one. Yeah.
Does Bamboo knows that it has to be pointing to that service?
No, I don't think so. This is this is into the nitty gritty. You'd probably ultimately come down to a human problem. You'd want to communicate, or possibly you want to merge your two feature requests into a single feature request. If your code is that interdependent, then those two changes are really one change. It's like if you've got distributed systems, but you're changing the API and the client at both ends. It's the same problem as that. You ultimately need to coordinate your changes. Hey, actually, we're technically out of time. Are we allowed to carry on? No. I'm being told, sorry, we're going to have to wrap up now. Thanks, everyone, for coming. I'll be hanging around today and tomorrow. Please come up and talk to me. This is all interesting stuff and good questions. Thanks.